So now we are going to consider triple integrals over general bounded domains. Now, so far we considered triple integral over a rectangular box, but here we mainly consider three simple solid domains, three types. The first type is given in this figure. Here we have a solid E in the xy z coordinate system, and this solid C has two surfaces bounded by the equations C equals to u2 of x comma y. That's the equation of the top surface. The equation of the bottom surface is given by u1 of x comma y. So basically your C values are bounded by two surfaces. Okay, and if you project this solid E onto the xy plane, then you will get a domain D, and your domain D contains all the x and y values. So basically this is your solid A. Also, if you look from the top, you will see only the domain D. Now in this case, the triple integral of f over the solid E can be written in this way. So we have this inner integral corresponds to the C variable, inner integral corresponds to the C variable, and C goes from the lower limit of C is given by the bottom surface, which is u1 of x comma y, and the highest C value is given by the top surface, which is u2 of x comma y. And these two integrals corresponds to the domain D, which is on the xy plane. So when we evaluate this integral, first we evaluate the inner integral, and after you apply the limits, you will get a function of x and y only. After that, this double integral can be solved using the techniques that we discussed in chapter 12.2 and 3. Okay, let's consider an example. This is the first example. In this example, we have to evaluate the triple integral of x dv, where E is the solid bounded by four planes. The first plane is x equals 0, the second one is y equals 0, third one is c equals 0, and the last one is x plus y plus c equals 1. Okay. Let's draw this domain E. So we have the x-axis, y-axis, and the c-axis. Now x equals 0 is the yc plane, y equals 0 is the xc plane, it's this one, c equals 0 is the xy plane. Now x plus y plus c equals 1 will be a plane like this. So the x-intercept should be 1, y-intercept should be 1, and c-intercept should be 1. Basically, your solid domain is this tetrahedron. This is your E. Okay. Now this surface is x plus y plus c equals to 1. In other words, c equals to 1 minus x minus y. Okay. Then the triple integral x dv over the solid E equals to triple integral of x dc dA. Now this inner integral corresponds to the c variable, and the lower value of c is given by the xy plane. And on the xy plane, c equals to 0. Therefore the lowest c value should be 0. And the highest value of c, in general, the highest value of c is given by the surface c equals to 1 minus x minus y. So if I consider a generic element dv, then the upper limit of c is given by this surface, which is 1 minus x minus y. And these two outer integrals corresponds to the domain D. And your domain D is on the xy plane. It is this triangle. That's your domain D. Okay, so let's figure out the limits of these two integrals. To find those two limits, we need to consider the xy plane, the region in the xy plane. That's your domain D. Now we are going to consider an area element on D. Then the triple integral can be written like this. Let's say dA equals to dy dx. This is 1, this is 0. Equation of this line is y equals to 1 minus x. Because on the xy plane, your c value equals to 0. Then you will get x plus y equals to 1. So x plus y equals to 1. Therefore y equals to 1 minus x. Using that information, we can figure out the limits of the middle integral. The lower value of y is given by the x-axis. Therefore it should be 0. The upper limit of y is given by the line y equals to 1 minus x. Finally, the limits of the outer integral corresponds to the x variable, and those two limits must be constants. The lower limit should be 0 and the upper limit should be 1. Okay, now we can integrate this. Okay. My first variable of integration is c variable. With respect to the c variable, x is a constant, and if you integrate a constant, you will get that constant times the variable of integration. Therefore you will get x times c The lower limit of c is 0, upper limit of c is 1 minus x minus y dy dx. Apply the upper limit first, then the lower limit minus the lower limit. And now we can simplify this integrand. So let's distribute this x. Then you will get x minus x squared minus xy dy dx. Next variable of integration is y. With respect to the y variable, we can treat x as a constant. So we have integral from 0 to 1. If we integrate x with respect to the y variable, you should get x times the variable of integration, which is y, minus x squared times y minus x times y squared over 2. Lower limit is 0, so this should be y. Upper limit is 1 minus x dx. Okay. If we apply the lower limit, you will get 0. So then we just need to worry about the upper limit. If you apply the upper limit, you will get x times 1 minus x minus x squared times 1 minus x minus x times 1 minus x squared over 2. Okay, let's simplify this.